Google File System is a proprietary distributed file system developed by Google for its own use. It is designed to provide efficient, reliable access to data using large clusters of commodity hardware. A new version of the Google File System is codenamed Colossus. Design: GFS is enhanced for Google's core data storage and usage needs, which can generate enormous amounts of data that needs to be retained. Google File System grew out of an earlier Google effort, Big Files, developed by Larry Page and Sergey Brin in the early days of Google, while it was still located in Stanford. Files are divided into fixed-size chunks of 64 megabytes, similar to clusters or sectors in regular file systems, which are only extremely rarely overwritten, or shrunk. Files are usually appended to or read. It is also designed and optimized to run on Google's computing clusters, dense nodes which consist of cheap commodity computers, which means precautions must be taken against the high failure rate of individual nodes and a subsequent data loss. Other design decisions select for high data throughputs, even when it comes at the cost of latency. A Gfs cluster consists of multiple nodes. These nodes are divided into two types, one master node and a large number of chunk servers. Each file is divided into fixed-size chunks. Chunk servers store these chunks. Each chunk is assigned a unique 64-bit label by the master node at the time of creation, and logical mappings of files to constituent chunks are maintained. Each chunk is replicated several times throughout the network, with the minimum being 3, but even more for files that have high end demand or need more redundancy. The master server does not usually store the actual chunks, but rather all the metadata associated with the chunks, such as the tables mapping the 64-bit labels to chunk locations and the files they make up, the locations of the copies of the chunks, what processes are reading or writing to a particular chunk, or taking a snapshot of the chunk pursuant to replicate it. All this metadata is kept current by the master server, periodically receiving updates from each chunk server. Permissions for modifications are handled by a system of time-limited, expiring leases, where the master server grants permission to a process for a finite period of time during which no other process will be granted permission by the master server to modify the chunk. The modifying chunk server, which is always the primary chunk holder, then propagates the changes to the chunk servers with the backup copies. The changes are not saved until all chunk servers acknowledge, thus guaranteeing the completion and atomicity of the operation. Programs access the chunks by first querying the master server for the locations of the desired chunks. If the chunks are not being operated on, the master replies with the locations, and the program then contacts and receives the data from the chunk server directly. Unlike most other file systems, GFS is not implemented in the kernel of an operating system, but is instead provided as a user space library. Performance: deciding from benchmarking results, when used with relatively small number of servers, the file system achieves reading performance comparable to that of a single disk, but has a reduced write performance, and is relatively slow in appending data to existing files. As the master node is not directly involved in data reading, the read rate increases significantly with the number of chunk servers, achieving 583 megabytes per second for 342 nodes. Aggregating a large number of servers also allows big capacity, while it is somewhat reduced by storing data in 3 independent locations. See also, Bigtable, Cloud Storage, CloudStore, Fossil, the native file system of Plan 9, GPFS, IBM's General Parallel File System, Hadoop and its Hadoop Distributed File System, an open-source Java product similar to GFS, list of Google products, MapReduce. References. Bibliography. External links, GFS, Evolution on Fast Forward, Q, ACM. Google File System Eval, Part 1, Storage Mojo.